In the last section of Chapter 6, we are going to kind of switch gears a little bit and stop talking about parallelograms, but instead go back and talk about quadrilaterals. So remember, if something's a quadrilateral, it just has four sides. The two shapes we're going to talk about today have four sides to them. They are not the kind that have two sets of parallel sides, so that's why they're not parallelograms. So the first one we're going to talk about is a kite. A kite is a quadrilateral with exactly two pairs of congruent, consecutive sides. So when we draw a kite, it's kind of like a rhombus, but a little longer. And when we talk about congruent consecutive sides, this side and this side are the same, and this side and this side are the same. So rather than being opposite, they're the ones right next to each other. Now, just like we have properties of everything else, we have properties of kites that we need to know. The first one is very similar to a rhombus, and it says that if a quadrilateral is a kite, then its diagonals are perpendicular. They form a nice 90-degree angle. And the other one says, if a quadrilateral is a kite, then one pair of opposite angles are congruent. So remember, in a parallelogram, both of the opposite angles would be congruent, but in this case, it's only the angles where the sides that don't match come together. So you can see how this one has 1/E and this has 2. The angle where that comes together and the opposite angle are always the same. But keep in mind that A and C do not equal each other. And you can see that with any drawing of a kite. These guys would be the same, but this guy and this guy, not so much. So let's do a problem. So I tell you that this thing is a kite, and PQR, this guy right here, is 78 degrees. And T to R to S, this guy right here, is 59 degrees. We need to find some other angles. So the first one it asks us to find is QRT. So this guy right here we need to find. And in order to do that, we need to think back to the triangle that we have in this shape right here. So, I know this is kind of hard without colors. So this big triangle right here is a triangle that has two sides that are exactly the same. And remember, we call that an isosceles triangle. And what you should remember about an isosceles triangle is these two base angles are exactly the same. Using that and the fact that this whole thing has to add up to 180, we can figure out this angle here that they asked us about. So I know that angle R plus angle P plus angle Q, which is at 78 degrees, has to add up to 180. And the thing that I know about these two things is they're exactly the same. So if I call them X, I get two of them. So 2x equals 78, or plus 78 equals 180. And then we just got to do a little math. So if I subtract 78 from both sides and divide by 2, I get 51. Now, if you can do this without all the math and just do 78 minus 180 and cut it in half, that's perfectly fine. So let's try the next one. So this stuff still holds true, but this time we are looking for QPS. QPS, this guy right here. So we just found that this little guy here was 51, and I know that these two added up equal this guy over here. So let's divide this up. I know that angle QPS equals 51 plus 59. And then all we got to do is add those together. So you end up with 110 degrees. Last one. This one asks us to find PSR. So P to S to R, this angle right here. Now we don't really know anything about this except what we have from this triangle again. So remember, this is a nice isosceles triangle here. You know these two angles have to be the same because these sides are the same. So if this one's 59, this has to be 59 also. And then we know that it has to add up to 180. So 59 plus 59 plus the angle we don't know has to add up to 180. So if you take 59 and double it, you end up with 118. And then if you subtract that from 180, you end up with 62. So a lot of the stuff with kites has to do with the triangles that we're familiar with and the two theorems that we have up here. So the next shape we're going to talk about is a trapezoid. And a trapezoid is a quadrilateral. Again, it's not a parallelogram. And it's because a quadrilateral has exactly one pair of parallel sides. Remember, a parallelogram has two. The parallel sides are called bases, and the non-parallel sides are called legs. So let's draw ourselves one. You're going to have two parallel sides. So these guys are parallel. Let's try drawing this straight. And then these guys here are my legs. So let's do bases in red. And legs we'll do in green. Those are our legs. So the trapezoids that we're going to talk about in this class are called isosceles trapezoids. So think back to an isosceles triangle. You knew that these two things were the same, and that told you that these two angles were the same. Well, an isosceles trapezoid is like somebody took a isosceles triangle and like chopped this off. And when they chopped it off, they made sure that the chopped off part was parallel to the bottom of the triangle. So you can think about it as this black shape here is an isosceles trapezoid with one pair of parallel angles. The thing that makes it isosceles is the definition of isosceles. They have congruent legs. And then we'll learn in these theorems what else that means. So if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So these two are always the same, and the ones up here are always the same. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So this is going backwards and saying if I know that these two are congruent, then these legs have to be congruent. So this is like the forward version of it, where this is like the backwards version of it. And then we haven't talked about diagonals in a while. So if a trapezoid is isosceles, its diagonals are congruent. So just like a rectangle, those two are going to be exactly the same size. And that goes both ways, meaning if you know that they're the same, then you have to have an isosceles trapezoid. And if you have an isosceles trapezoid, then you know they're the same. So let's do some problems. I need to find the measure of angle F right here. So what I do know is that this is isosceles. So if this guy's 49, this guy has to be 49 also. The other thing I know is that both F and G are exactly the same. So let's call them both X. And because this is a quadrilateral, we know all of these have to add up to 360 degrees. So X plus 49 plus 49 has to equal 360 degrees. And then this just turns into a problem with some algebra. And remember, if you can do this in a calculator without actually thinking through the algebra, that's totally fine. So you get 2x equals 262. Cut that in half, and you end up with x has to be 131. The other way that you could have done this is, remember these two lines are parallel. And if I slice this like a transversal, you know that this guy here and this guy here have to add up to 180 degrees. And if you know angle G, you also know angle F. Either way, So let's try the next one. So because they tell me that these two sides are the same and these two are parallel, I also know that these diagonals here have to be congruent. So when they tell me J to N is 10.6 and N to L is 14.8, I can find this total distance right here, this KM, because I know they have to be exactly the same. So that means that JL has to be equal to KM. So the things that make up JL are 10.6 and 14.8. So if we do a little math and add those together, we will get the total length of KM. So 10.6 plus 14.8 gives us 25.4. And those have to be exactly the same. All right, last one, number 4. It says find the value of x so that PQST is isosceles. So when we come back up here, it says if a trapezoid has one pair of congruent base angles, then it's isosceles. So we want to say that 2x squared plus 19 has to equal 4x squared minus 13. And if that's the case, then these two would be the same, making it an isosceles trapezoid. So let's do a little math. I'll subtract 2x from both sides, add 13 to both sides, divide everything by 2, so we get 16 equals x squared. And then remember, we got to take the square root of both sides, so we get x equals 4. And because it just wanted x, we're done. The last thing we got to talk about is the mid-segment of a trapezoid. Think about that word. Mid means middle, and segment means part of a line. So the mid-segment of a trapezoid connects the two mid-points of the trapezoid's legs. So think about your trapezoid. Let's draw one here. Remember, these are the bases because they're parallel. These are the legs. So somewhere right in the middle of the legs, you're going to have the midpoint. The mid-segment is the line that connects those two. That is your mid-segment right there. We only got one theorem for this one, and it says the mid-segment of a trapezoid is parallel to each base. So now we have 3 things that are parallel here. And its length is half the sum of the lengths of the bases. So that means you're basically finding the average of these two things. What's the distance right in the middle? So if I tell you that this guy is 10 and this guy is 20, the length of your mid-segment has to be in the middle, so it has to be 15. That's all that theorem's saying. So let's try this problem. So first, notice what we have going on. The fact that it gives us these little slashes right here tells us that x is the midpoint of FE. These double slashes over here tell us that y is the midpoint of HG. So that makes XY the mid-segment. Once I know this is the mid-segment, then I can say that these two things up here are true. I need to find EH. That's what I don't know. I need to figure out how these two are related. So remember, you're finding the average. So all you got to do is take your two bases, so 25 and x, add them up, cut them in half, and it equals your mid-segment. And then you got to do some math to solve this. So we'll multiply both sides by 2, and we'll end up with 33. And then we'll subtract 25 from both sides, and we will get 8. The other thing you can do if your brain works this way is say, how do I go from 25 to 16.5? And you'll have to subtract. And you'll have to subtract 8.5. And then you got to do exactly the same down here. So if you have 16.5 minus 8.5, you end up with 8, which is what we have. So that's all you need to do tonight. We will go over this stuff tomorrow in class. Make sure if you have a question on something, you put like a little star next to it or a question mark or something so that I know to go over it in class. Hope you enjoy your night.